These are your notes for Unit 5, Day 1 of Algebra 1. If you would like to see the warm-up, the review question, or any homework questions we covered in class today, or test questions we covered in class today, just look at the finished notes. So today we are going to talk about how to tell whether or not an ordered pair, so a given x and y coordinate, whether they would be a solution to a system of linear equations, so two or more linear equations. We will be able to solve a system of linear equations, so two or more equations, by graphing them on a coordinate plane. And we will be able to tell how many solutions a system of linear equations will have. Will they have one solution? Will they have no solutions? Or will they have infinite solutions? So a system of linear equations would look like the following. 2x minus 3y equals negative 18, x plus 2y equals 6, x plus y equals 2, y equals 3, or y equals 2x minus 6 and y equals x minus 3. So these are systems of linear equations. So by themselves, each of these are their own separate equation, but we want to know what happens if we graphed them together on the same coordinate plane. So if we wanted to graph 2x minus 3y equals negative 18, you've got two ways to do this. We could graph using intercepts, or we could solve for y. I'm going to solve for y, so I'm going to get the y by itself, so I'm going to minus 2x from both sides, and I'll have negative 3y equals negative 2x minus 18. And then I'll divide every part by negative 3. And then my equation is going to be y equals positive 2/3 x plus 6, because a negative divided by a negative is going to be a positive. So to graph this, this would be 6 up, so 1, 2, 3, 4, 5, 6. And then the slope's telling me to move up 2 over 3. And so this pink line would be that top original function, 2x minus 3y equals negative 18. And now I'm going to solve the second one. So my second equation was x plus 2y equals 6. So I want to be able to graph that. So I'm going to subtract x from both sides. And I get 2y equals negative x plus 6. And then I'm going to divide both pieces, or all the pieces, by 2. And so I have y equals negative 1 over 2x plus 3. So this one's going to start at positive 3 on the y-axis, and then it's going to go down 1 over 2. And then if I connect them, that would be my second line. So I have a brown line and a pink line, and together they make a system of equations. What we're going to be most interested by in this system is the one point that they have in common. So that one point that they would have in common, we're going to call that the solution. So it's the one ordered pair. It's the one xy that they have in common. That's going to be what we're going to be looking for in this unit. We're going to call that the solution to the system of equations. So let's look at our next one. X plus y equals 2. So if I want to graph x plus y equals 2, let's do this one by finding its intercept. So remember to find the y-intercept. We let x equal 0, and we solve for y. So if I plug in 0 for x, I get 0 plus y equals 2. And so y is going to equal 2. So my y-intercept is going to be 2. So I have the point 0, 2. To find an x-intercept, you let y be 0. So if I plug in 0 for y, I get x plus 0 equals 2. So my x-intercept is going to be positive 2. So I have a x-intercept at positive 2 and a y-intercept at positive 2. So that is going to be the line x plus y equals 2. We could have also solved for y, so we could have subtracted x from both sides, and I would have y equals negative x plus 2. So that means I would start at 2 on the y-axis and then go down 1 over 1. And notice if I went down 1 over 1, down 1 over 1, it'd be the same line. The second line is the line y equals 3. And so that is the line where y is always equal to 3. So it's a horizontal line, 3 high. So this is going to be the equation of the line y equals 3. And so remember, the one place that we're interested in is the point that they have in common. So that's going to be their solution. So it looks like that's going to be the point negative 1, positive 3. We're going to learn how to tell whether or not that is accurate in a minute, but that looks to be what the solution would be. So we want to figure out where those two lines would intersect, where they meet each other. On the next one, we have y equals 2x minus 6 and y equals negative x plus 3. So negative 6 would be the y-intercept for the first one. So 1, 2, 3, 4, 5, 3, 4, 5, 6. So negative 6, and then the slope is 2 over 1, so up 2 over 1. So here's my first line. And then the second line is negative x plus 3, so it's going to start at 3 and then go down 1 over 1, and then connect those 2 points. Connect those 2 points with a line. And then again, what we're looking for is the point where the red and purple line intersect, and that's going to be my solution. So those are systems of linear equations. They're linear because when you graph them, they make lines, and they're called a system because there's more than one of them. All right, so the solution again is the intersection point. So where the two lines meet is going to be the solution. So we're trying to figure out where they intersect. So if these were the two equations that I'm talking about, and I want to know where they meet right here. It doesn't look to be exactly perfect, but we're going to estimate it. And it looks to be the point x is negative 1 and y is negative 2. So that would be my best guess at what the solution to that system would be. Negative 1 for x and negative 2 for y. On the next one, where do they intersect? It looks like they intersect right here. And that is the solution. X is equal to 1 and y is equal to 2. So it looks like those would intersect at the point 1, 2. Why don't you guys pause the video and try the next one? Where do those two lines intersect? So it looks like these two lines intersect at this point right here, and it looks to be the point negative 1, negative 2 again. So again, the solution to a system of equations is the point where the two lines would intersect each other. So how do we know if a given solution is going to be a solution to a system of equations? Well, you have to plug the ordered pair into both equations. It has to be a solution for both for it to be a solution to the system. So is the point negative 1, positive 4 a solution to that system? Well, in the point negative 1, positive 4, x is negative 1 and y is 4. So we're going to plug in negative 1 for x and 4 for y into both of those equations and see if it's a true statement. So let's plug it into x minus 3y equals negative 13 first. So x is going to become negative 1, y is going to become 4, and we want to know if we plug in negative 1 and 4, will it be negative 13? Well, negative 1 minus 12 is negative 13. So it's a solution to the first equation, but for it to be a solution to the system, it has to be a solution to both. So it needs to be a solution to both. So now we're going to plug it into negative 2x plus y equals 6. So plug in the same ordered pair. X is negative 1, y is 4. Does it work? Negative 2 times negative 1 is 2, and 2 plus 4 is equal to 6. So since the point negative 1, 4 is a solution to both, then yes, the point negative 1, 4 is a solution to the system. So plug your ordered pair into both equations. If it works in both equations, then we call it a solution to the system. So let's try one more together. Is the point 8, 5 a solution to the system? So if I plug in x is equal to 8 and y is equal to 5, does it work? So let's plug into the first one. X minus y is equal to 3. Is 8 minus 5 equal to 3? Yes. Let's plug it into the second one. X plus 2y equals 18. So x is 8, y is 5. So it's not equals, that's plus. So 8 plus 2 times 5, is that equal to 18? Yes, it is. So then, yes, the point 8, 5 is a solution to the system. Why don't you guys try? Is the point 1, negative 1 a solution to the system? You can pause the video and try. All right, so this is when x is equal to 1 and y is equal to negative 1. So let's plug it into the first one. 2x plus 3y equals negative 1. If I plug in 1 for x and negative 1 for y, is that a true statement? 2 plus negative 3 equals negative 1. It works in the first one. Does it work in the second one? Negative 2x minus y equals 1. So that'd be negative 2 times 1 minus negative 1. Is that equal to 1? Well, this is negative 2 plus 1. Negative 2 plus 1 is negative 1. Whoops. Since it's not equal to positive 1, it's not a solution to the system because it doesn't work in both equations. So it is not a solution. So the point 1, negative 1 is not a solution to the system because it doesn't work in both equations. So let's try some more solving systems by graphing. So to solve a system of equations by graphing, you're going to graph, and then you want to find the intersection point. And we're just going to estimate the intersection point if it doesn't look perfect. So if I wanted to solve the following system by graphing, the first step was I've got to be able to graph it. So 3y equals 9x minus 6 was my first equation. To graph this guy, I got to solve for y, so I'm going to divide everybody by 3. And I have y equals 3x minus 2. So I'm going to start at negative 2, and then I'm going to go up 3 over 1. Connect those points. And there's my first linear equation. And then I'm going to take my second one, 3y minus 2x equals 1, and I'm going to solve that equation for y. So I'm going to add the 2x over, and I get 3y equals 2x plus 1. Then I will divide everybody in this equation by 3. And I get y equals 2/3 x plus 1/3. So in this equation, I'm going to start at 1/3, so that's about right here. And then it's telling me to go up 2 and over 3. So that's up 1, that's up 2, and then I need to go over 3 from there. So I'm going to go right here. So those are going to be my 2 points, and then I'm going to connect them. And there we go. And so it looks like my solution is right here, and that looks to be about the point. I think I went a little bit too dark on that. Right here. So that looks to be about the point 1.1 comma 1.2. So 1.1 over on the x-axis, not even 1.2, 0.2 up on the y-axis. So that looks to be about my solution. Doesn't look perfect, but that's what I mean. We'll estimate what our solutions are when we're graphing. On the next one, we have x is equal to 4. When x is equal to 4, that's a vertical line, 4 high. So 1, 2, 3, 4. So that's going to be a vertical line, 4 over. And there's my first line. So that's x equals 4. And then on the next one, 2y minus x is equal to 6. We can either solve using intercepts, or I'm going to solve for y. I'm going to solve this equation for y. So I'm going to add x over. And then I get 2y equals 1x plus 6. And then I'll divide everybody by 2. And so I get the equation y equals 1/2 x plus 3. So I'm going to start at 3. And then I'm going to go up 1 over 2 and then connect them. And then my solution is where they intersect. So they look to intersect right here, and that looks better than the other one. That looks like they intersect at the point 4 and then 4, 5. How would we tell if that's the real solution? Well, you would plug it into both equations. Well, in the first equation, x is always equal to 4. And in my point, x is equal to 4, so that looks like it works. In the second one, if I plug in the point x is equal to 4, y is equal to 5, I would get 2 times 5 minus 4. Does that equal 6? It does. So the point 4, 5 is the correct solution. All right, let's solve the next one by graphing. So 6y plus 4x minus 6 is equal to 0. So 6y plus 4x minus 6 is equal to 0. I'm going to solve this for y. So I'm going to subtract the 4x and add the 6 over. And I get 6y equals negative 4x plus 6. And then I'll divide everybody by 6. And so I get y equals negative 2/3 x plus 1. So I'm going to start at 1. And then I'm going to go down 2 over 3 and then connect those 2 points. And that's my first line. In my second line, I have negative 2x equals negative 3 plus 3y. I'm going to add the 3y over so it's with the x term. And I get negative 2x plus 3 equals 3y. I've got to solve for y, so I'm going to divide everybody by 3. and I get negative 2/3 x plus 1 is equal to y. So I'm going to start this one at positive 1, and I'm going to go down 2/3. What do you notice this time? It's the exact same line right on top of itself. We call these coinciding lines because it's the exact same line over the exact same line. How many solutions do you see on that? Where do they intersect? Well, they intersect everywhere. How many points are there on a line? There's an infinite amount of points. So how many solutions will these two lines have? They have all solutions in common. And so we say that this has infinite solutions. This is different than all real numbers because obviously not every single point, like the point right here, the point 10, 10, isn't a solution because the point 10, 10 isn't on the lines. So we don't say all real numbers. We just say that they have infinite solutions because every point on the line is a solution. So that takes us into the number of solutions to a system. So your options are they could have one solution, they could have no solutions, or they could have infinite solutions. So let's go through what each of those would look like on a graph. So y equals 2x minus 1. We would start at negative 1 and then go up 2/1. That would be my first line right here, y equals 2x minus 1. And then the second line would be, we would start at positive 3, and then we would go down 2/1. And then there would be my second line. And notice how many solutions do these have? This has one solution, so they intersect at one point, and it looks like they intersect at the point 1, 1. And again, you could check by plugging in 1, 1 into both of those equations, and it looks like the point 1, 1 works. So if the two lines intersect at one point, then we say that they have one solution. Y equals 1/2 x plus 1, so this would start at 1 and then go up 1/2. And so that would be my first line. And then my second line starts at negative 2 and then goes up 1/2. And then remember, we want to know where do these two lines intersect. Well, that pink line and the green line are never going to intersect, so they never intersect. So how many solutions will they have? These guys have no solutions. What else do we call those two lines? They're parallel. So when two lines are parallel, they're never going to intersect, so they have no solutions. So if two lines are parallel, they're going to have no solutions because they'll never intersect each other. On the next one, we have 2x plus 4y equals 8. Let's graph that one with intercepts. So if I plug in 0 for x, I would have 4y equals 8, and so y would be 2. So the point 0, 2 is a solution. And then if I plug in 0 for y, I would get 2x equals 8, so that would be 4. So 1, 2, 3, 4. The point 4, 0 would also be a solution. So if I wanted to graph that first one, my line would look like this. And then the second one, we have y equals negative 1/2 x plus 2. So on this one, we would start at 2, and then we would go down 1/2, down, oh, now look, it's the exact same line again. So notice, it's the same line over the same line. We would say that these have infinite solutions. So if you're going to graph the same line twice, we say that they have infinitely many solutions in common. So they have infinite solutions, not just one or none. They have infinite solutions. So those are your three options for how many solutions there could be to a system of linear equations. So without graphing, determine how many solutions these equations would have. So basically, we need to figure out if they're parallel, are they the same line, or neither of those options. So if they're parallel, then that means that there would be no solutions. If they're the same line, then they would have infinite solutions. And if they're neither parallel or the same line, then they would have one solution if you were to graph them. So let's look at that first one, 3x plus 4y equals 6. To figure out if they're parallel, they need to have the same slope. So we need to find the slope of that first line. So 3x plus 4y equals 6. So to graph this, I would have to solve for y. So minus the 3x minus the 3x. And 4y equals negative 3x plus 6. Then I'm going to divide everything by 4. and I get y equals negative 3/4 x plus 6/4, or 3/2. So these are my two lines. Y equals negative 3/4 x plus 3/2, and y equals negative 1/2 x plus 5. Well, obviously they're not the same line. They're not the exact same, and they don't have the same slope. One slope is negative 1/2, one is negative 3/4. Since they're not the same line and they're not parallel, if you were to graph these, they would have one solution. They would intersect at one point. All right, why don't you guys pause the video and try the next one? Would they be parallel, which means they would have no solution? Would it be the same exact line, so they would have infinite solutions? Or is it neither of those, so there would be one solution? So go ahead and pause the video and try the next one. All right, on this one, we know that the second line is y equals 1/2 x minus 2, so the slope's 1/2. On the second line, we have x equals 2y minus 3. I'm going to solve for y, so I'm going to add the 3 to both sides. And I have x plus 3 equals 2y. And then I'm going to divide both sides by 2. So I get 1/2 x plus 3/2 equals y. So that's my second line. And my first line was y equals 1/2 x plus 2. Well, notice these two lines have the same slope. They're both 1/2, but they're not the same exact line because one has a y-intercept of negative 2 and the other one has a y-intercept of 3/2. So since they have the same slope, but they're different lines, then that means that the two lines are going to be parallel. And if they're parallel, they're going to have no solutions because they're never going to intersect.